So the first few aren't too bad, and then they start to get a little bit more difficult, right? So one we're able to do, I'm assuming. We're good with 2? We're good with 3? 4 is a little weird. Are we good with 4? And then 5 is where it starts to get weird. Did anyone figure out how 5 works? How does 5 work? Divide what? So what rule tells us to divide? So we have to have a good reason to divide. Okay, so if you have a radical, the 5th root of x is the same as x to the 1/5. So what we actually have is log x to the 1/5 to the 20th. And then the rule with your exponents is if you have an exponent raised to an exponent, what do you do with them? You multiply them. So what is 1/5 of 20? 4. So you have log of x to the 4th. Is that an answer choice? Yes. Which one is that? R. Okay, so that's R. So this one is R, so we solved that one. And that's because we just had to remember how radicals work. Okay, so number 5 is done. I think number 6 is a little bit easier than number 5. You just have to remember what to do. So x to the 3rd on top divided by 1 over y. What do you have to remember to do here? You have a fraction on the bottom. What do we do with fractions on the bottom? Keep, change, flip. So I've got log base 3. Keep the x to the 3rd the same. Change it to a multiplication problem. Flip the bottom. Y over 1. So does one of the answer choices have log base 3 of x to the 3rd times y? You said it's n? Oh, the very top one. Okay. So number 6 is n. The answer at the very top. Okay. Okay. For number 7, what has kind of helped me with these ones that have the number in the front but also a number in the front is I kind of do the inside of the parentheses first. So I kind of ignored the 1/2. I just dealt with this part, so it was log x plus 3 log y. So I took the 3 and I made it the exponent for the y to the 3rd. And then this was a plus, so I made it the multiplication. So I did x times y to the 3rd, x times y to the 3rd. And then I went back and I dealt with my 1/2. So the 1/2 goes to the x, the 1/2 goes to the y to the 3rd. So that was x to the 1/2, y to the 3/2, because 3 times 1/2 is 3/2, and then over z squared. Can you guys tell which answer choice that's probably? That's O. So now we just have to make it make sense. So if you look at answer choice O, we can see that the z squared, that one's kind of obvious. X to the 1/2 is the same thing as the square root of x. So that part probably makes a lot of sense. The part that's a little bit weird is the y's. And this is reaching back to Math 2, actually, with how radical simplification works. So what they did is they said y to the 3/2 is the same thing as if you had y to the 2/2 times y to the 1/2. Do you guys see how 2/2 plus 1/2 gives you 3/2? Does that make sense? 2/2 plus 1/2 gives you 3/2. So the 2/2 they to put in the front, 2/2 is just 1. There's the y to the 1 power. And then the 1/2 is a leftover, and that 1/2 stayed underneath the radical. That's what they did. They simplified it. So y to the 1 goes in the front, y to the 1/2 stays underneath the radical. So you had an x to the 1/2 and a y to the 1/2, and that stayed underneath. Does that make sense? Okay. An alternate way to write this is you could have said, you could have written log, and you could have put a square root, and you could have put x, y to the 3rd over z squared. That would have been correct as well. X to the 1, y to the 3rd. And then the square root is the half part, the divide by 2 part. So that would have been accurate. Okay. I started number 8. What do I need to do to number 8 to finish it? So I started off by saying x squared divided by y to the 4th. And I did y to the 5th divided by x. But I haven't dealt with the 3 and I haven't dealt with the 2. So I'm distributing the 3. So this, instead of being x squared and y to the 4th, what would it be? x to the 6th and y to the 12th. So we're taking the 3 and we're moving it as an exponent to each of these. So the x squared is being raised to the 3rd power. The y to the 4th is being raised to the 3rd power. And when you raise them to those powers, you multiply. So it'd be x to the 6th, y to the 12th. So I'm going to have log base 3, x to the 6th over y to the 12th. What does this plus mean in the middle? Multiplication, so I'm going to say times. And now I can go ahead and do this one. I have y to the 5th, and I've got a 2 in the front. So what would this one become? Y to the 10th. And then on the bottom, I had x to the 1, or just x, and so the x would become x to the 2nd. Okay. So when we simplify this, what does this become overall? Yeah, we have some of the x's cancel. We end up with x to the 4th on top is all that we have. Some of the y's cancel. We end up with y to the 2nd on the bottom is all that we have. So x to the 4th on top, y to the 2nd on the bottom. And then what answer choice is correct for number 8? Answer choice A for number 8. All right, for number 9, we have log base 3, and then what should I be writing? Okay, x divided by what is this part? Okay, so this was x to the 3rd. So it was y times x to the 3rd. And then what do we do with this 2? We multiply it by both of these. So it's going to be y to the 2nd. And then the x to the 3rd is being raised to the 2nd as well. Why did I put these on the bottom? Because it had the minus. Okay, so overall we've got log base 3 of x divided by what? Y to the 2nd, x to the 6th. And that's not going to be the final answer. What's the final answer going to be? Okay, 1 over y to the 2nd, x to the 5th. Okay, what answer is that? M. Okay, 9 is M. Okay. How are we feeling about the properties? We getting better at them after this worksheet? Whew. Okay, let's try the next one. The next one starts to add another layer to the properties. So we've got just log. If it has no base, what's the base? 10. So this is log base 10, technically. So what should I be writing? It's got a plus in between. these two fractions are being multiplied together because it's got a plus in between. So just multiply the two fractions. So we got x squared over x squared minus 1 times x plus 1 over x. Okay? Now, with this one, we've got some simplifying that we can do, right? Some of the other problems had simplifying. So x squared and x, those can simplify, can't they? Okay, what can simplify? Yeah, you can take an x off the bottom, and you can take one of the x's off the top, and it just leaves an x behind. Okay, what about the x squared minus 1 and the x plus 1? Can those simplify? Yes. We gotta factor this one, though, to simplify them. And you want to remember how to factor x squared minus 1? You're close. X plus 1, x minus 1. So what we have right now is we have x over x plus 1, x minus 1. So on the bottom here, this was called difference of squares. It was a quadratic that was called difference of squares. It can be factored. And then on the top, we have x plus 1 over nothing, over 1, because we canceled it out. And so what can reduce this time? The x plus 1s. Okay, so now that we've done our reducing, we have log base 10. And then in our fraction, what do we have? X over x minus 1. We can't reduce anything because x over x minus 1 is a subtraction problem. This is a division problem. And division and subtraction don't cancel. So if you try to cancel out your x's, then you're trying to cancel division with subtraction. Those don't cancel. Okay? So at this point, we are finished. What answer choice is this? O. This is O. We were able to cancel these two right here because this is a multiplication problem. And then the top divided by the bottom, that's a division problem. And we were canceling multiplication with division. That's why it worked. Same thing over here. Multiplication, one times the other. And then top and bottom, that's division. So we were canceling multiplication with division. We can't do it over here because this is division. And then x minus 1, that's subtraction. That's why it doesn't cancel. Okay? All right. Let's look at number 11. So how should I write number 11? It's going to be a fraction. How do we know it's going to be a fraction? It's got a minus sign. Okay, so what goes on the top, what goes on the bottom? X squared plus 2x plus 1 goes on top. What goes on the bottom? X squared minus 1. Okay, and then what do you guys think we're going to be doing with the top and the bottom? Yeah, we're going to be simplifying those. So on the bottom, we already know that that factors x plus 1, x minus 1, because we did that in the previous problem. X plus 1, x minus 1. And then for the top, we have to look for two numbers that multiply to 1 but add to 2. Two numbers that multiply to 1 but add to 2. 1 and 1. So x plus 1, x plus 1. And then what cancels out? Yeah, the x plus 1 and the x plus 1. And we can cancel these because we've got multiplication canceling with division. So multiplication and division are opposites. We're allowed to do that. So our final answer for this one is log x plus 1 on the top, x minus 1 on the bottom. We can't cancel out the x's because we'd be trying to cancel addition and subtraction with division, and addition and subtraction are not the opposites of division. They're the opposites of each other, but they're not the opposites of division. All right, so number 11 corresponds with which answer choice? B. Okay. And then for number 12, we got some minuses here. Okay, so we're going to have log. And what should we write? X plus 2 divided by, and then it looks like this one has a divided by as well. So it looks like we've got a fraction on the bottom. Okay, and then for our fraction on the bottom, what's on the top of the fraction? X squared minus 4, and what's on the bottom of the fraction? Minus x minus 2. So this is saying divided by, so now you're talking about the bottom of your fraction. But the bottom of your fraction has its own fraction because it's in parentheses and it's got a minus. Yeah, we had one up here that was minus and it was in parentheses, but it had a plus in it. So when we did this one, we said, where did my sticky go for that one? When we did this one, we said, it's a division problem. And then when we did this division problem, we said, that's a plus, so it's on the bottom of the division, right? But since it's a plus, they're multiplying together. For this one, it's a division problem, but since it's a minus, they're dividing by each other. It wasn't two separate fractions because it just said minus one time. Yep. So this is saying it's a division problem, but you only have one thing on the bottom. This is saying it's a division problem and the bottom is division also. Yeah, does that make sense? Okay. All right, so let's look at... Oh, it's not today, but it's going to be. No, you're fine. Yeah, because I don't trust any of them after that, but you can look at them. So that's the key. Yeah, it's because first it says but it should have been A. Should have been a variable A. And then 3 right answers, this one with no work. Does this work? You have to... This work doesn't support. Well, it does, but you have, it's the ambiguous case, so you have to have found the second situation to know that it doesn't, that it's only one triangle. You have to find the second situation to know that it's 2 triangles, and she didn't do either of those things. And then... No, you can't. And then this one, there's no work for the right answer. So I said 3 right answers in a row, plus not knowing that. And then here I asked if it was a 9, and she said, "Oh no, it's a 91." I said no, it's actually an A. Yeah. So here's this if you want to bring it back. Yep. All right. So what do we do when we have a fraction and the bottom is a fraction itself? What do we do with that? Keep, change, flip. So I'm going to go ahead and write this. I've got log. I'm going to keep the top as x plus 2. And then I'm going to change this. I'm going to actually not write that. I'm going to change this to a multiplication problem. And then for the bottom of the fraction, I'm going to flip it. So keep it, change it to a multiplication problem, flip the bottom. Keep it, change it, flip it. And now we got some factoring to do. Yeah. Any ideas on how to factor? So this one looks like a factor already. I'm going to put parentheses around it so we can recognize it as a factor. And then any ideas on how we could factor either of these? So the first one, we have to look for what multiplies to -2 and adds to -1. Multiplies to -2, adds to -1. -2 and 1. Okay, so we have x plus 2 times x minus 2, x plus 1. Okay, and then on the bottom, we have difference of squares. So we're going to have two sets of parentheses, one with a plus, one with a minus. And it's x plus 2, x minus 2. Okay, and I forgot to write my log, so I'm going to keep my log in the front here. And technically right now it is log of all of this stuff. Log of all of that. But we have a lot of stuff that cancels. What's going to cancel? The x minus 2's, the x plus 2's, and what's left over? X plus 1. Log of x plus 1. So what is the answer choice for this one? S? Okay. I don't know. Okay. 12. This joke is older than you guys, I'm sorry. Yeah. Yeah, if you guys look up, well, go ahead and take your phones out and look up saloon. Like, look up that word. If you guys were watching like a Western like movie, they wouldn't call a bar in a Western movie. They would call it a saloon. But if you look up a saloon on Google, you should see it. Saloon bomber.
Here it is. You know, for some reason that's why I pictured in my head, and I was like, okay.
It's just funny because the joke failed because it's outdated. Saloon bomber.
I'm glad they thought they did.
That's so good.
You have to pick,
But here, let's. See, guys, they're like old Western bars. You guys see? Yeah, it's a bar. It's just like in an old Western. It's like right. That's where you have like John Wayne and the jokes of like this is like a one-horse town, and they like go out on the dusty road, and each man like draws his gun and they shoot each other. Yeah, that's always happens outside a saloon. It's a bar. Saloon bomber. Get it? No? Okay. Let's move on, shall we? Go ahead and put your name on that. Keep it for now. I'm probably going to have you guys turn it in for credit, but I think that was some good problems, so we're going to keep them for now. But we're going to take some notes so that we can learn the next thing. So the title of your notes are going to be solving log equations. Solving log equations. All right, so here is your first example. I'm just going to go through several examples, and then I'm going to give you guys a chance to maybe ask some questions, and we'll see if we have any issues with these. There's two basically different types of problems you'll see when you're solving log equations. There's problems that have logs on one side, and then there's problems that have logs on both sides, and they kind of work out a little bit differently. All right. So you can still kind of do what we were doing with the previous problems. If there's an x, and by previous problems I mean solving when we were trying to find the inverse of an exponential equation or the inverse of a log equation, you can do that, but only if the variable is in one spot. If you have the variable in two spots, then doing order of operations backwards does not work, okay? So this problem, order of operations backwards, is going to work just fine because the variable is only in one place, not two. So if you want to walk through and think about, is there something you could add or subtract? Is there something you could multiply or divide? Is there an exponent you could get rid of or introduce or whatever? And then get inside the parentheses. Or grouping symbols. If you want to think of it that way, you can. But just keep in mind that only works on problems where there's only a variable in one place. And some of the problems we're going to do today will not have that. All right, so first thing for this problem, there's not something we could add or subtract to the other side. There's not something we could add or subtract to the other side to get the x alone. There's not something we could multiply or divide to the other side to get the x alone. So the very first thing we're going to have to do is get rid of the log base 3 by introducing something that's kind of exponential in the problem. So I'm going to introduce a base of 3 and a base of 3 to get rid of the log base 3, because we know that the opposite of logs is exponentials. So the opposite of logs is exponential. So I'm doing a base of 3 and a base of 3. So I've got x minus 7 is 3 to the second power. And what's 3 to the second power? 9. And then from there, I am inside my grouping symbols, my parentheses, I'm inside of them. And now I can go back to the beginning and just solve it. This one's pretty easy to solve. So how do we get x alone? Add the 7. So x equals 16. All right, this one is going to require a little bit more effort. We're still going to have a situation where we have logs on one side, but we're going to have two places where there's an x value. And so we are not going to be able to do our order of operations backwards. Now, anytime I have the word log written twice, I can't get rid of the log. I have to condense it first, and then I can go through the process of getting rid of the log. So for me to condense this down and get it so the word log is written one time, what should I do? Yeah, make it a fraction. I've got a minus. That means this is a division problem. So I'm going to condense this down. Log base 2, make it the division problem that it is. So I've got x plus 2 on the top, x minus 2 on the bottom equals 1. Now at this point, I can go ahead and get rid of the log. So there's nothing I could add or subtract over to get the 2's closer to being alone. There's nothing I could multiply or divide over for the 2's to be closer to being alone. Even though I have x's in 2 spots, those first 2 steps are still kind of beneficial, even if this isn't like the perfect way of doing the problem. So the next thing I'm going to do is get rid of the log by doing what? Base of 2 on each side. Base of 2, base of 2. So the base 2 and the log base 2 cancel out, and I have my fraction x plus 2 over x minus 2 equals, and then 2 to the 1 power is 2. Okay, now I don't want this to be a fraction anymore, so how am I going to make it not a fraction on the left side? I'm going to multiply what? The x minus 2, I'm going to take this x minus 2, I'm just going to multiply it over to the other side. So if I times x minus 2 on the left side, times x minus 2 on the right side, on the left side it cancels out. And I'm left with x plus 2 on the left side, and on the right side, what do I have? 2x minus 4. Okay. And then what should I do? Subtract the 2 over. And then I can get my x's alone. So negative x equals negative 6, and so x equals 6. Okay. Now, whenever we are solving log equations, we have to make sure that we are not getting an extraneous solution. In math, extraneous solutions are solutions that you can mathematically solve for, but numerically they don't work in the problem. And with logs, you always run the risk of getting extraneous solutions. In a logarithm, you cannot take the log of a negative number. So if you tried to do log, I'm just going to hit the log button. If I tried to do log of negative 1, my calculator says error. You just can't do it. You can't take the log of a negative number. So what we should get in the habit of doing for every single problem is going back to the very beginning of the problem and just plugging our answer in to make sure that it makes sense. So what I'm going to do here, and I'm going to show you guys a trick on the calculators, is I'm going to take my answer and I'm going to store it in for x. So I'm going to take 16, and I'm going to hit the store button, which is down here, STO. Store that for x right up here. Store it for x. So on my calculator, it looks like 16 arrow x. 16 is stored as x, and I should hear everybody typing that because everyone's trying it. 16 is stored as x. So now every time I hit the x button, all it does is it pops out a 16. And then what I'm going to do is I'm going to go back to the original problem, and I'm going to type in the original problem with the x in the problem. So the original problem said log base 3 of x minus 7 equals 2. I'm just going to make sure that it equals 2 like it's supposed to. So I'm going to hit the math button. Remember, if you hit math up, that's how you get your log to a different base. So I'm going to hit the math button, up, up, log base 3 of x minus 7, and I'm literally typing x. Log base 3 of x minus 7 equals 2. I got the answer right. Now for the next one, my answer was 6. So I'm going to type 6 store x. So it's going to have 6 arrow x. So I'm storing 6 in for x. I'm going to go back to the original problem, and I'm going to type the original problem with the x's in, knowing that the calculator is plugging in 6 for the x's for me. So math up, up, log base 2 of x plus 2 minus log base 2 of x minus 2, and the answer should be 1. Oh, I gotta make sure I have my parentheses correct. I have extra parentheses in there somehow. Yeah, I think I just have to retype it. Math up, up. Log base 2, yeah. X plus 2, it is 1. Minus log base 2, x minus 2. Yeah, equals 1. Okay, so, and sometimes they work, sometimes they don't work. A lot of students will start to internalize, oh, negative answers don't work. That is not the case. You cannot take the log of a negative. That is true. So it is more often the case that negative answers are going to be the ones that trigger it and make it so it's not true. But there are negative answers that work. So just be careful of that, okay? Let's go ahead and look at another one. Sorry, I'm looking for some that work out a little bit differently so we can see how those go. Okay, for this one, we're going to do log base 8 of x plus 6 plus log base 8 of x minus 6 equals 2. All right, so what should we do? We're going to condense it down. We have the word log written twice on the same side. We can only have the word log written one time on the same side. So I'm going to write log base 8. It says plus in between, so what should we be doing? Multiplying. So I'm going to have x plus 6 times x minus 6. Yeah, these are conjugates. These are the factors of difference of squares, right? X plus 6, x minus 6. And when you FOIL those out, or when you multiply those out, what do you end up getting? Yeah, you get x squared minus 36. Okay? So now, if we want to get rid of the log in the problem, how do we undo log base 8? We put a base 8 on both sides. Base 8, base 8. The base 8 cancels out with the log base 8. and we end up with x squared minus 36 equals, what is 8 to the second? 64. And then, does anyone know how to solve that problem? Add 36, add 36. X squared equals 100. And we square root it. And when you square root, how many answers do you get? 2. You get positive 10 and negative 10. And then let's go back and check these answers. So I'm going to do 10 stored as x. And then I'm going to type in the problem. So log base 8 of x plus 6 plus log base 8 of x minus 6. I'm going to make sure it equals 2. Okay. Now I'm going to store negative 10 as x. And the nice thing when you're typing, when you're double checking two different answers, is you don't have to type it the second time. You can just go up, highlight this, and like copy paste it, and it will take the new x value that you stored and plug it straight into the same thing that you did before. So I'm going to plug it in. And this time when I plug it in for negative 10, I get an error message. So what does that tell me if I get an error message? Negative 10 is not a good number to plug in. Positive 10 is good. Negative 10 is not good. So negative 10 is not an answer, but positive 10 is. So if we look back at the problem, negative 10 was the issue. Negative 10 plus 6 is negative 4. Negative 10 minus 6 is negative 16. For both of these, you would be taking the log of a negative number. That's the issue with the problem. Does that make sense? The issue is with the negative 10. Okay. How do we feel about the problems with the log on one side? You got to condense it down. You got to make sure there's only one. Okay, let's try a couple problems with logs on both sides. Okay. So for this one, I'm going to start you off on some easier ones. ln 3x minus 1 equals ln 2x plus 5. You're like, Ms. Rice, you said we're starting on easier ones, and then you gave us ln problems. Yeah, it's just, well, guess how you would do this problem. You have a log on each side, an ln. You have a log on each side. If you have a log on each side and there's only one on each side, whenever you have the same thing on each side, you can just cancel it out. Yeah, it's really nice. If there's the same thing on each side, just cancel it out. So this is actually 3x minus 1 equals 2x plus 5. As long as there's the same thing on each side, you can cancel them out. All right, what do we do from there? Minus the 2x. X minus 1 equals 5. Then what do we do? Plus the 1. X equals 6. And we're not going to leave it there. We're going to make sure that this answer is a valid one. So we're going to say 6 stored as x. And then I'm going to type it in. ln 3x minus 1. Make sure that's the same decimal as ln of 2x plus 5. My decimals are the same. Got it right. Yep. So this is me storing my 6 for my x. And then I typed in ln 3x minus 1, ln 2x plus 5, and I checked my decimals and they're the same. Okay. Let's try another one. All right, for this one, we got log x plus 9 plus log x equals log 10. Log x plus 9 plus log x equals log 10. We got 3 logs. That's 1 too many. So whenever we cancel logs, we can only cancel 1 on each side. And we can't just cancel 1 on each side because there's a plus sign right here, right? So we have to condense first. We got a plus sign, so what does that tell us? Multiplication, right? Okay, so we're going to write log of x plus 9 times x equals log 10. And what do I get when I multiply those together? X squared plus 9x. Okay. Now, at this point, when I have 1 log on each side, then I can ditch the logs. It would just be 10. Mm-hmm. So we got x squared plus 9x equals 10. And do you guys recognize what kind of equation that is? It starts with a Q. It's the x one. It's a quadratic equation, which means it cannot equal 10. It has to equal 0. So how do I make it equal 0? I'm going to subtract the 10. So I've got x squared plus 9x minus 10 equals 0. So I'm looking for 2 numbers that multiply to negative 10 but add to positive 9. 1 and negative 10, is that quite right? Negative 1 and positive 10. Okay, so my factors are x minus 1, x plus 10, and that makes my answers what? Okay, x equals negative 10, x equals 1, but before I decide, those are both my answers, I got to plug them back in, make sure they work. So negative 10 stored as x, and then I'm going to start typing it in. Now, since this says log and not log base something else, I can just use the log button. So log of x plus 9 plus log of x. Well, now I just typed it in and I got an error message. So what does that tell you? Yeah, I started with the negative 10. I tried to type it in. I got an error message. So what do we know about the negative 10? Not an answer. Okay, negative 10's no good. Now, what happens if I have 2 answers and both of them are bad? Yeah, the whole equation's wrong. You would say no solution. So that's a possibility also. Okay, so I just typed 1. I'm going to go back up here and copy that, pull it down so I don't have to type it again. Okay, so I typed it in, I got 1, and now I'm going to type log 10, make sure that's 1. It is, so 1 is a good answer. Okay. How do you guys feel about these? Pretty okay? So I think what we're going to do is I'm going to hand out the worksheet, and we don't have too much longer in class left. So I think what I'm going to say is on the worksheet, I want you to try, I want you to do 4 problems on the worksheet. 4 problems on the worksheet, okay? So now the problems I want you to do on the worksheet, because the worksheet is double-sided. At the bottom of the worksheet, it says joke 15. That's the one you're going to do. What did the vampire say to his patient? That's the punchline, or that's the joke. Okay? And you guys are going to choose 4 problems to do, any 4. Doesn't matter which one, so you can search for the easiest ones. We're eventually going to do the whole thing, but for today, you're just going to do 4. Sound good? All right.